So if we go into lipids, lipids are going to be our fats and oils. And the difference between them, fats are going to be solid at room temperature. So you can think lard, butter, and then oils like avocado oil, extra virgin olive oil. These are going to be liquid at room temp. Dang it. Okay. If you remember back to when we talked about the properties of water, we said water is a universal solvent. But what was our little catch-22 there? It was the fact that everything that's polar is soluble in water. So lipids are nonpolar. Since lipids are nonpolar, they're not soluble in water, or they're insoluble in water or other polar solvents. But they are soluble in nonpolar solvents. Okay, so lipids have a few different functions. I'm going to do f of x for functions. So this is functions. Go ahead and whenever you were in middle school science, you would say, okay, what is the difference between a carbohydrate and a carbohydrate and a fat? What do you always think? What's the difference? The difference is talking about energy storage. So we talk about carbs being those short-term energy and then those lipids being long-term energy. So we know one function of lipids is energy storage. We can use these as an energy source. They also function as building blocks to the cell. So once we get into the cell in this next little lecture objective set, we will get into the plasma membrane, and that's made up of phospholipids, so building blocks of cells. Okay. And also function in insulation and cushion. Insulation meaning that it traps heat well, and cushion meaning that it protects against trauma. The tissue that we store our lipids in is called adipose tissue. Alright, we want to break down the different types of lipids now. The first thing that we're going to do is go through neutral fats. Neutral fats are also called triglycerides. Let's look at the different types of triglycerides. So we're still in lipids, and now we're doing neutral fats or triglycerides. And let me write up what else we'll do, and then we'll go through all of them one by one. Alright, so the different classes we'll go through are neutral fats or triglycerides, then phospholipids, then steroids, then eicosanoids. But breaking down our neutral fats or our triglycerides, we can break these down into a few. So let's do saturated and unsaturated, polyunsaturated, trans, and omega-3s / omega-6s. Let's see what all these mean. Okay, saturated fat. I guess first we should draw a lipid, or a triglyceride in general, just so that you can see what a triglyceride would look like. So in our case of neutral fats or triglycerides, we're going to start with a glycerol molecule, which it has some more things than this, but the oxygens are what we're looking at right now. Actually, I'll just throw up glycerol real quick. Okay, cool. So This is a glycerol molecule. We don't really care about we don't really care what the structure is, but what we want to see is a triglyceride has a glycerol molecule, and then these are called fatty acid tails. That's a fatty acid tail. That's a fatty acid tail. That's a fatty acid tail. So, what we're going to separate are saturated, unsaturated, polyunsaturated. And the way we do this is by looking at the number of double bonds. So this is going to be our first, what I call, mental map. So what a mental map is, it allows you to have similarly related concepts that are going to have similar information but have differences. And you'll see what I mean. So for this example, what we're going to look at is this has no double bonds. And let's get some other information up there first. These are solid at room temperature. So is this an oil or is this a fat? This is a fat. And then we want to ask, well, where do these come from? Animals or plants? Saturated fats come from animals. And the last thing that we want to do, and give me a second, I'm going to do that in a different color. Okay, cool. So the things that we're looking at in this mental map, we're saying 4 different things because these are all triglycerides. We need to ask ourselves, okay, well, how do we differentiate them? Because when you come up to a test question, maybe we'll use the word triglyceride and it might give a characteristic, or it'll say what it's doing in the body and ask you to say what kind of triglyceride it is. So we want to know what similar information, like what are basically the topics we need to know about triglycerides, and then how do we separate them. So the topics about triglycerides that you want to know are 1, double bond characteristics, 2, state of matter at room temperature, 3, animal or plant production, 4, effect on cholesterol. So this is our first mental map. So now what we're going to do is go through each of these and we're going to fill out our mental map, and then whenever you come up to a test question, you don't have to go through, if we have 4 pieces of information for each of these, this is 16 pieces of information. Instead, if you come up to a test question and you see the word double bond, then you go to your mental map and you say, I know my double bond for saturated, I know my double bonds for unsaturated, I know my double bonds for polyunsaturated. So that's how I like to approach this class. When you get to a test question, you only want to think of like a maximum of 10 things from the class. That's the amount of information you want running through your head. You don't want 100,000 different things that you're learning all semester. So these mental maps are a way to do that. Let's continue. Unsaturated. These have 1 double bond. Unsaturated are going to be liquid at room temperature. They mostly come from plants. And they are going to have no effect on cholesterol. Let's go to poly. Poly is going to be 2 or more double bonds. And as you can see, I did it in this order so that you could see the progression. We have no double bond, we have 1 double bond, now we have 2 or more. Solid, liquid, these are going to be liquid at room temp. These are going to come from plants. And these are going to decrease cholesterol. So saturated, increase cholesterol. Unsaturated, no effect. Polyunsaturated, decrease cholesterol. Cholesterol is not necessarily a bad thing. It's in all of your plasma membranes. It's very important. But overaccumulation of cholesterol on the walls of your capillaries and blood vessels can lead to decreases of blood flow, heart attacks, stuff like that. And then we have this trans fat. So I'll get to this one. This was made in the 1980s as a flavoring agent, and when you see stuff like hydrogenated vegetable oil, that is a trans fat, and this is really high increases of cholesterol. Now with this picture, I want to identify what we have this idea with saturated, unsaturated, and double bonds, all that kind of stuff. So if you look at this, we have no double bonds. No double bonds is what kind of triglyceride? that means that this is no double bond saturated fat. But this is only one of 3 fatty acids. So looking at this next fatty acid, we're come across no double bonds. Boom, double bond. So we know that this is at least an unsaturated fat. If I go back and I look at my list, I say 1 double bond. Okay, that must be unsaturated. But again, we've only looked at 2 of the 3 fatty acid tails. So now looking at this last one, we can identify multiple double bonds, and this is where we can say, okay, this is a polyunsaturated fat. Now, really quick with organic chemistry, just in case you want the little extra, these right here, these would be hydrogens. These would all be hydrogens. So a carbon can have, and again, this is way more organic than you need to know for this class, but a carbon can have 4 bonds attached to it. And if you look, like if we're looking at this, this is this carbon, and I'll use a different color. This carbon that I just did a circle for is attached to 1 carbon, 2 carbons, a hydrogen, and a hydrogen. So that's 4 bonds. Okay. Here, so if we look at this next one, this carbon is attached to 1, 2, and then it's attached to this carbon 2 times. So that's where the 4 bonds are. Getting rid of all that, that's how we see how we get these double bonds. So mental map. Ask yourself, when you come to a question about a triglyceride, ask yourself, what is the double bond characteristic? What is my state of matter at room temperature? Where is this coming from, an animal or a plant? What is my effect on cholesterol? And then just ask, if there's no double bond, was it modified to have no double bond? If so, it's a trans fat and it's really bad on the production of cholesterol. Omega-3 and omega-6, this is showing right here. This little symbol is omega. So omega is your last carbon, and if we go in 1, 2, 3 carbons in, we get a double bond. That would make this an omega-3. So omega-3 has a double bond, and technically, to be honest, I don't know. I literally just got this picture off Google, so I have no idea whether you'd call this an omega-3 or an omega-6, because if you go 1, 2, 3, you have a double bond, but if you go 4, 5, 6, you also have a double bond. Not that important, just wanted to make an observation. Again, let's ask ourselves, for omega-3, omega-6, double bond characteristics. Yes, it has a double bond, or else it wouldn't be described this way. So this omega-3 is saying a double bond at the 3rd carbon from the omega carbon, which is that last one. So we know it has a double bond. The next thing we need to ask ourselves is state of matter at room temperature. These are oils, so like these are fish oils and stuff. Omega-3s, fish oils are high in omega-3s. And then what's our 3rd question? I don't want to look. Let me ask myself. So we have double bond. We have where do they come from? We want to know the effect on cholesterol as well as where they come from. So I guess this would be, so omega-3s. We have double bonds, yes. Double bond. These are liquid. I don't know if you can get these. My brain just goes straight to fish oil, so I don't know what plants are rich in omega-3s and omega-6s. Maybe avocados or nuts or something. I don't know. I'm kind of guessing there. And then the last one is effect on cholesterol. And these are going to decrease cholesterol production, as well as they contain anti-inflammatory properties. And we will get into inflammation next semester. Crazy to think how far away that is, but how fast it will come up. Alright, omega-6s, he makes a note. They help reduce cholesterol, not as good as omega-3s. They're good for skin health. Alright, those are our classes of triglycerides. So when you go, crap, I can't remember what my triglycerides are. What I like to do is I just associate the word triglyceride with the word cereal box. Triglyceride cereal box, because when I was a kid and I used to sit there and I'd eat bowl and bowl of cereal, I'd love to, I mean, I wouldn't read the nutrition per se, but I always read the cereal box, and I'd always read the nutrition label. So when I think of triglycerides, my head immediately just goes to a cereal box, and then I say, okay, well, what fats are on that cereal box? I know saturated fats on there. I know unsaturated fats are on there. I know polyunsaturated fats are on there, and sometimes you'll see those unsaturated fats listed as monosaturated, and you know trans fats are on there. Typically you don't have a label that says omega-3 fats, it will just say includes omega-3s or something, but that's what I do. When I think triglyceride, I think food label.